Let's take a look at warm-up 58. Number 1 says, find the scale factor. So, if the dimensions of this smaller rectangle are the height is 2.5 inches and the base is 3.5 inches, and we look at the larger rectangle, the base is 21 inches and the height is 15 inches, what's the scale factor? So what do we talk about scale factor means? What are we doing to the dimensions of this one to get the dimensions of that one? Anybody know? So we're having a little bit of a struggle thinking about this one. Let's look back at this. So 57, we did this one on Monday, right? And it says use the scale factor of 1 to 3 to create a new figure. So we knew that 1 to 3, what did 1 to 3 mean? Yes, for every 1 inch over here, we're going to have 3 inches over here. So we said that means 3 times bigger. Do you remember doing that? So if for every 1 inch here, if I have 5, 1, 2, 3, 4, 5, for every one of those, the other one's going to have 3. This inch will have 3. This will have 3. So that is multiplying 5 times 3. 5 times 3 is 15, right? And 3.5 times 3 we said is 10.5, right? So they give us the scale factor and then we multiply and we got the dimensions of the new triangle. So if they've already done the multiplying for us on this one, what's the inverse operation? Division. We can divide, right? So for the height, we can say 15 divided by 2.5. What is 15 divided by 2.5? Do that on your calculator. What did we get? 6. And so the base, we're going to say 21 divided by 3.5. What do you get? 21 divided by 3.5. What do you get? 6. So what's the scale factor? How many times bigger is this rectangle than this rectangle? It's 6 times bigger. So for every 1 in the first rectangle, we have 6 inches in the second. It's a 1 to 6 ratio. This one is 6 times bigger. Does that make sense? So if over here we know that we use that to multiply, if the multiplying's already been done, then over here we're going to divide. Now you should always get the same number to show that it's a 1 to 6 ratio. Does that make sense? Questions? No. Okay. Find the area of the new figure. Find the area of the new figure. So how do you find area? They're both rectangles, so what's the formula for area of a rectangle? Base times height. Area equals base times height. So over here, do we need the area of this one to find the area of this one? No, what we need to do is we need to solve for x. How do we solve for x? Set up a proportion. So 9 feet for the height, 15 feet for the base equals x for the height and 5 feet for the base. So you can cross multiply. 5 times 9 is 45. And 15 times what is 45? Or you can say 45 divided by 15. What would you get? 3. So x equals 3. So now what's the area of the new figure? 3 times 5 equals 15 feet. All right, questions on that one? Pretty straightforward. Yes. Okay. I just want to talk briefly about the warm-up for tomorrow because I know.
Teachers and students, please pardon the interruption.
I just want to talk about tomorrow's warm-up. Number 1, a triangle is shown below. If the image is dilated by a scale factor of 1.5, what is the perimeter of the new triangle? So there's a couple of words in there that we need to discuss so that you'll know how to do this tomorrow without a lot of questions. What's one of them that you think that we need to talk about? Dilated. What does dilated mean? Anybody know? Anybody been to the eye doctor? Makes bigger, right? When you have your eyes dilated, I think they make your pupils bigger, right? And so what we're going to do is we're going to dilate this triangle, and we're going to make it bigger by a scale factor of 1.5. What does that mean we're going to do to all of those sides of the triangle? If we're going to make it bigger, we're going to do what, Hudson? Yes, we're going to multiply every side by 1.5. So we're going to get a new, bigger triangle, and that we multiplied all those sides by 1.5. And today, on the second problem, we found the area, but this one says find the perimeter. And I don't know that we've talked about perimeter in a little while. You've been doing area and perimeter since 3rd grade. We should know how to find the perimeter. Anybody know what perimeter means? Asia? Add up all the sides. It's the distance around, right? When you learned about perimeter in elementary school, you learned it was like putting up a fence around the outside edge, right? So you have to add up all the sides to get the perimeter. Just wanted to make sure that we knew what those two things meant before you looked at those tomorrow. All right, any questions on the warm-up? No? Okay. Let's take a look at our notes for today. We are on our first lesson of Unit 5. There are only 6 units this year. We will be done with this unit probably next week. It's a quick unit. The next one's pretty quick too. And if we stay on track and don't have any days off from school, we will finish all of our new lessons before spring break. We'll be done with all of the 7th grade units. And then when we come back from spring break, we'll review for a couple of weeks, and then it'll be Georgia Milestones time. And then we're going to get ready for 8th grade. I already know what the 8th grade teachers want us to do at the end of the year. So we'll be ready to keep on working. Okay? So first lesson of this unit is about using probability to make a prediction. So we're going to use what we've learned this year about ratios and proportions. And we are going to use probability. And we are going to take some survey data, and we are going to make some decisions and make some predictions about bigger populations based on data from sample populations. So let's take a look. Up here, probability. Let's write the definition of probability. That is the chance that some event will happen. Is it a good probability or a bad probability? Well, we'll have to find out. But probability is the chance that some event will happen. And in math, it's the ratio of the number of favorable outcomes to the number of possible outcomes. And we'll talk about what that means in just a minute. But it is a ratio. You should be writing these things down. If we were to come around and look, you should have this written on your paper. So what do we mean by probability? We just wrote a definition of it, but so as a mom, I'm famous for if my kids come up and go, hey, can I go spend the night with my friend this weekend? And I'm like, maybe. What do you think that means? Maybe. No. Most likely not. Probability is less than 50%. That means I want to say no, but I don't want to say it right now. But I'm really not feeling it. So that's kind of the likelihood is less than a 50-50 chance, right? It's not very good. If they came up and said, do you want me to clean my room? What's the probability I'm going to say yes? Probably 100%. Yeah, if you're asking me if I think you need to clean your room, the answer is probably, yeah, you probably needed to do it last week, right? Right. Yeah, there is a problem. That was probably a little facetious. I don't know that my children have ever asked me that. But again, you can have 100% probability, right? That means it's definitely going to happen. And then you can have like a 0 chance, right? So we talk about that usually out of 100%. But here what we're going to do is we're going to try to put some numbers with that probability. Okay, and we talked about in our vocabulary the other day, population is everybody that you're looking at in a group of people. So here, let's take a look. This table shows the results of a survey of 150 students. That's your sample. They're only going to talk to 150 students at a school. That's not the entire population. This is just their sample size is 150 students. So we're going to need that number in just a couple minutes. That's our sample size. What is the probability that a student will play basketball? So here's the collection of our data. So when they went around and they asked these 150 students, what's the question? What is the probability that a student will play basketball? So I guess they went around and asked people what sport they play or, you know, what they do for fun. And so when we look over here, out of that 150 students, how many said they like basketball? 30. So that's 30 out of how many? 150. So let's create our first ratio. That's 30 out of 150. 30 out of 150. You can make a ratio out of that. Okay? And as you're going through and doing this work, a lot of times they're not going to tell you what the sample size is. I would have to figure it out. If they didn't tell me it was 150, how can I figure out how many people they asked? Yeah, add them all up. You would just take these, add them all up, and they should equal 150. That would be your sample size if they didn't tell you that explicitly. Okay, so can I simplify this if I want a smaller ratio, if I want to really understand what that means? So you could reduce this fraction on your calculator. Let's see what that would look like. Let's see if I can get that to work better. 30 over 150. And does anybody remember how to simplify or reduce a fraction? Just hit equals. 1/5. That's 1 out of every 5 students. 1 plays basketball out of every 5 students. That number seems to make a little bit more sense to me, but you could still use this one. But this is kind of making it make sense. Out of every 5 students they surveyed, 1 would have said basketball. As a percent, anybody know what that would have been as a percent? 20%, right? 1 divided by 5. Or you could take that and say fraction to decimal button, and you would have gotten 0.2. So that's roughly 20%. So that's kind of using everything that we've learned so far in math this year to kind of make that make sense. So 30 out of 150 is about 20% of the people. So now what we're going to do is we're going to use this data from the survey, and we're going to make a prediction. Use probability to predict for a population using ratios and equations. So we're going to say that there are 1,000 students at RMS. Predict how many will play basketball. So remember, part over whole, part over whole. So if the entire sample size was 150, and the part that played basketball was 30. So if we're going to set it up, where is the 1,000 going to go? Right? So this is total students. This is basketball. So we want to know how many would play basketball out of the total students. So we're going to put the 1,000 right here. And then do we know how to solve that? Yeah. Cross multiply and then divide. So 1,000 times 30. $30,000. And then what? Divide by 150. Divide by 150. And so our prediction is 200. And does that make sense? Should it be a number less than 1,000? Yes. So then our statement would be, I predict 200 students at RMS play basketball. All right, seem easy enough? So what you're doing is you're using a survey, you're getting a ratio, and then you're taking that ratio and you're setting it up as a proportion to make a prediction. So it's all math that we've already done. We're just using it for a different purpose now. Questions? All right, we're going to put it in our journal. I think we're on page 119. And let me see what we're going to call it. I think it's probability and predictions, but I don't remember. That was interesting. What happened? I lost my screen. Oh, there we go. Okay. So 119. Probability and predictions, 119. All right, I don't think we've started our table of content the other day, so make sure that you did. I still had some room over here underneath mine, but really not that much space, and we only have 2 units left. So I went over here, Unit 5, skip a couple of lines, And then page 117 was that Unit 5 vocabulary, and 119 is probability and predictions. So make sure you get your table of content up to date, and we're going to look at the skills practice in 2 minutes. Make predictions. For exercise 1 through 4, use the table and the following information. A survey of students' favorite sports was taken from a random sample of students in a school. The results are shown in the table. All right, question 1. What is the size of the sample? What do we need to do to find the size of the sample? Add them up. 8 plus 3 plus 5 plus 4. That looks like 20 to me. Anybody know? 8 plus 3 is 11, plus 5 is 16, plus 4 is 20. So the sample size is 20 students. That's probably would not be enough for a real survey, but we'll go with their numbers. We won't judge today. All right, everybody see how we got that answer? What is the probability that a student will prefer soccer? So what's the probability? What's the likelihood? Out of 20 students, how many? 8 out of 20. Could we reduce that if we wanted to? We could divide both of them by 4, and we could say that equals 2/5. So 2 out of every 5. Could we change that to a percent? How could we do that? Because that's a probability. It's a good probability. You could be asked that on Georgia Milestones. 2 out of, let's see, wait a minute, 2/5. And change that to 0.4. And what is 0.4 as a percent? 40%. So is that a good probability they're going to prefer soccer, would you say? 40%? It's less than half, right? Because half would be 50%. So it's not even half of the students. What's the probability that a student will prefer volleyball? Is the probability higher or lower? It's lower, right? It's 5 out of 20. And that would simplify to 1/4. And 1/4 as a percent is 25%. So a quarter of the students, 25%. So you should be able to report your answer as a fraction and a percent. And we know how to work with both of those. There are 550 students in the school. Predict how many students at the school prefer track and field. So remember, we're going to have to use a proportion. We're going to have to use the probability up here. Track and field is 4 out of 20. So track and field out of total equals how many for track and field out of 550. Everybody see how we did that? This is track and field. This is total students. This is track and field. This is total students. So 4 times 550 is 2,200, and then divide that by 20, and you get 110. All right, the next section says use the percent equation to help you solve. Do you remember the percent equation? What's the percent proportion? Part over whole equals percent over 100. Part over whole equals percent over 100. We've been using that for a few months now. So when it says use the percent equation, that's what it's talking about. The part over whole equals percent over 100. So we're still making predictions. We're still using data that was collected, but now it's going to be collected as a percent. And we can use the percent proportion. Gardening. A survey showed that 74% of a nursery's mail order customers spent more than $100 on plants each spring. Predict how many out of 125,000 mail order customers will spend less than $100. So here's what we need to look at. This is 74% spent more than, but we want to know what percent. Let's see. Now we're going to predict how many spent less than. So it's not 74% spent less than. If 74% spent more than, what's the percent for less than? Anybody remember how to find that? It's going to be 26. So out of 100%, if 74 spent more than, then it should be 26% spent less than, right? So 26 over 100, because it's percent over 100. So out of how many of the 125,000 total customers, what's the part that's going to spend less than? So where does the 125,000 go? The bottom or the top? The bottom. It's the whole amount. So 125,000. So we need to figure out the part. So what do we need to do? Cross multiply and then divide. And our answer is 32,500. $32,500 customers will spend less than $100. So in years past, lots of students have gotten hung up on wanting to use that $100 in the math. Did we need to use that $100 in the math anywhere? No, that was just creating the problem for us. So don't get hung up on extra numbers like that. All right, so you're going to work on 6 and 7, and you are going, no, let's not do both of those. Let me pick one. Work on number 6. That's the only one you need to do on that side. Do number 6. And then the back side. That's really just 10 problems. I did most of the front with you. Okay, so you've got plenty of class time to get started on this. If you have a question, come see me or Coach Baker.